Today we're going to be talking about 5-6, the quadratic formula, and the discriminant. Okay, so let's kind of review. It says describe how you would calculate the position of the driver after 1 second using the equation in your textbook. So regardless of what the equation is, guys, if I'm given 1 second and I want to find out how long it's going to take, I would just plug in 1 for the t, which is time, into the equation. So we're going to use the same concept when we're talking about the quadratic formula. So I want you to go ahead and write down the quadratic formula. It's x equals negative b plus or minus the square root of b squared minus 4ac, and it's all divided by 2a. Okay, so let's look at the second part. It says we're going to identify the values a, b, and c that you would use to solve 2x squared minus 5x is equal to a negative 7. Now remember, in order for me to label a, b, and c and solve a quadratic, my quadratic has to be equal to 0. So my a is going to be a positive 2, my b is going to be a negative 5, and c is actually going to be a positive 7. Because if it's a negative 7 on the right-hand side of the equation, when I add 7 to make my equation equal to 0, that's what makes it a positive 7. Okay, so let's look at the table below. Okay, it says suppose that you are solving 4 quadratic equations with rational coefficients, and you have found the value of the discriminant for each equation. In each case, give the number of roots and describe the type of roots that each equation will have. So my first one is going to be 64. 64 means that I'm going to have 2 roots, and it's real, and they're rational. If I have a negative 8, so less than 0, I'm still going to have 2 roots, but they're going to be complex roots. If I have 21, which is a positive number that is not a perfect square, I have real irrational numbers. Just like 64, that was a perfect square, that's why they were rational. And my last one, if I have my discriminant equal to 0, there's going to be 1 root, they're going to be real, and it's a rational root. Okay, so what I want you guys to go ahead and do is on number 3, scratch out 3, and I want you in that space to copy this chart down. Okay, so again, on number 3, go ahead and cross that out on your page, and in that empty space, I want you to copy down these charts. So you should have the discriminant part labeled and the type and the number of roots. So take a minute, you might have to hit pause, but copy this down for your notes. Okay, so looking at the back of the page, again, y'all, my quadratic formula, it says the solutions of ax squared plus bx plus c is equal to 0, and a cannot be 0, and there's your quadratic formula, and it's exactly what I had you copy on the front page. So what you're going to do is using this quadratic formula right here, you're going to answer questions 1 through 15, and I'm going to work an example for you. So let's look at the example that was given to you. Using the equation, this was my A, my B, and my C. Okay, so my A is a positive 1, my B is a negative 5, and my C is actually going to be a negative 14. So A was 1, B was a negative 5, and C is going to be a negative 14 because, again, remember my equation has to be equal to 0. So using that information, I'm going to plug it into the equation, which is what I did here on step 2. When I multiply it out, I end up with 5 plus or minus the square root of 81 and is all divided by 2. Well, the square root of 81 is 9, so I have 2 answers. I have 5 plus 9 divided by 2, and I have 5 minus 9 divided by 2, which is where I get my 2 answers of negative 2 and 7. So using that same information, I'm going to work problem 1 for you. Okay, looking at problem 1, I have x squared plus 2x minus 35 equals 0. Now this equation is already equal to 0, so I don't actually have to solve anything. It's already in the correct format. So I'm just going to label A, B, and C, and I'm going to plug it into the formula. Okay, so the first step in problem number 1, I want you to go ahead and label your A, your B, and your C. Okay, so again, there's my quadratic formula. I have negative b plus or minus the square root of b squared minus 4ac, and it's all divided by 2a. So my a in this equation is 1, b is going to be 2, and c is a negative 35. So I'm going to replace my letters, or my variables, with those 3 numbers. So using that information, I'm going to use this first step. I have negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 35, and it's all divided by 2 times 1. Now make sure every number that you replace the variable with, you have in parentheses. That's going to save you a lot of effort when you plug it into the calculator. Okay, so when I multiply that out, I have a negative 2 plus or minus the square root. Well, 2 squared is 4. And if I do a negative 4 times 1 times negative 35, I get 140. And it's all divided by 2 times 1, which is just 2. I'm going to simplify it even further. So I have negative 2 plus or minus 4 plus 140 is 144, all divided by 2. Once I get to this step, I'm actually able to simplify it even further. So the square root of 144 is 12. So I have negative 2 plus or minus 12 is divided by 2. Now, if it will help, you know you're going to end up with 2 answers on this problem. It will help to rewrite it out. So I have a negative 2 plus 12 divided by 2, and I have a negative 2 minus 12 divided by 2. So negative 2 plus 12 is 10. 10 divided by 2 gives me x equals 5. Negative 2 minus 12 is a negative 14. Negative 14 divided by 2 gives me x equals negative 7. So your 2 answers for problem number 1 is that x equals 5 and x equals negative 7. So you're going to work the rest, 2 through 15, in class tomorrow using the exact same formula.